guys, this is Ms. Martinez, and in this video we are looking at phase shift and tangent graphs. So I want to begin by just recalling a little bit of information here. This curve right here, this is the graph of y equals cosine of x. And the reason we know that this is a cosine curve is the fact that at our y-axis right here, it's starting at its maximum. And at 2 pi, which is right here, this right here is 2 pi. At 2 pi, it is also at its maximum. And one thing that you know about a cosine curve is that halfway between there, which is at pi, right here, halfway, it will be at its minimum. And that's a really important point. Why don't we write that down, that halfway is the minimum for a cosine graph. Now here, this one next to it, this is a sine graph. And that is known because at 0, on our y-axis, it starts at its intercept. It starts at the y value of 0, and it ends 2 pi there as well. You have one crest and a trough, and that halfway point for a sine curve, halfway for a sine curve is an intercept. All right, so that's just a little bit of review, and what I want to move on to now is something called a phase shift. And by phase shift, all that is a horizontal movement or shift of a trig graph. And that happens, your phase shift occurs because of this value right in here, and we denote it with an H. It is the opposite of that H value. Your movement is going to be opposite of what you see right in here. Okay, so take for example, and let me make really clear here. Our B value, the one that affects the period of your trig function, your B value is outside, and the phase shift is grouped inside parentheses with your x. Okay, so let's look at an example. Let's say, for example, that we had y equals 5 sine, and then inside parentheses here we'll have 3 for our b value, and inside of parentheses again we have x minus pi over 2 and then minus 1. All right, so what would be our phase shift for this function? Well, we would be moving pi over 2, and we'll go opposite of what the sign says. This says negative movement, but we are going to move positively, so that will be right pi over 2. Our sine function is going to translate to the right pi over 2 units. It's going to actually get shifted this way. This function would get, every single point would be moving over the same amount. That amount is pi over 2. All right, and this graph of course would have a lot of different changes. It would not look just like this. Our amplitude would be different, so would our period, and we would have a vertical shift as well. But it would now lastly have a movement right pi over 2. And so we're going to see how it is that we go about doing this when we do have a lot of changes. Let's look at number 1 here, this first example. So let's begin by answering amplitude, period, and then our phase shift, and that will allow us to graph. Okay, so our amplitude for this one is, well, my A value right here is 1, so the absolute value of 1 is 1. We'll have an amplitude of 1. Our period is we use the equation 2 pi divided by our B value. And our B value for this equation, it again is what is in front of your X. And if there was something, like, let me contrast it here, your B value is what is in front of your X no matter what, okay? So here we'll have our B value is 1/2. So we're looking at 2 pi divided by 1/2, which you can't divide by a fraction, so you'd actually be multiplying by its reciprocal. The reciprocal of 1/2 is 2, so we're looking at a period of 4 pi units. And our phase shift, we look at this H value, and our H value is pi over 4, but now is it to the right or to the left? Well, this is positive. We're going to move in the opposite direction of what we see, and that will be left. All right, pi over 4 left. And we don't have any vertical translations here, just the only changes are going to be with the period of our cosine function and then its movement to the left. So let me give you guys a really good trick when it comes to graphing these phase shifts. What you want to do is begin by graphing it without the phase shift. Graph what you would have if you just had cosine of 1/2 x. And so what would that look like? Okay, well, it would mean that we're only going to see half of our cosine curve in 2 pi. Okay, so that would mean I would start at my high point, at my maximum, which would be 1. And I want you to, right now, put little x's. Put little x's because we're not actually going to graph this. This is not the final, but we're going to graph, and these are going to be kind of like our little marking points. All right, at 2 pi, I'm only going to be halfway through, so that's going to be at my halfway through is going to be my minimum, so I'll mark that right here. And halfway between there, halfway between my max and my min is where I cross my axis, so I'm going to cross it at pi. And then I'd have a nice reflection over here, so at negative pi, I'd have an intercept, and at 2 pi, I would have a minimum. Now what we're going to do is we are going to take and we're going to move these little x's, and we're going to actually plot points for this graph pi over 4 units to the left. Well, pi over 4 is halfway between 0 and pi over 2. So really it's just one of these little divisions here. So we're going to move this over pi over 4 units. We're going to move this point over pi over 4 units, just 1 over. We're going to move this one over. I know it's kind of off the graph, but gives us an idea here. Rough sketch. This one over pi over 4 and this one over. And it is these dots that I am going to connect to make my cosine curve. That is the complete graph for this cosine function with a change in period and phase. Let's do some more. Let's look at this one. this is a little bit different from the format that you see here. To be able to accurately give your phase shift, it does have to have your B value factored out. So what we're going to do is we're going to rewrite this with our B value factored out. So what would that be? It would be -2 sine. Now let's factor out that 2, meaning I'm going to divide both of these terms by 2. When I do that, 2 divided by 2, that's just going to leave me the x value. And when I divide pi by 2, well, that just gives me pi over 2. And then don't forget that vertical shift of 1 there at the end. All right, so let's begin to answer some of these questions here. Amplitude, our amplitude is the absolute value of -2, which is 2. I do know that this negative is going to make my graph flip, though. I'm going to put a little asterisk here so I don't forget that. So it's not going to look like a snake. I'm sorry, it's not going to look like crest trow. It's going to look like trow crest. Okay? Let's look here at our period. The period is 2 pi divided by 2, which is just pi. Our phase shift is going to be pi over 2 units, opposite of what we see here, negative. So we're going to move positively, which is right. And I want to put in my vertical shift as well. It is down 1 unit. Okay, so let's begin to graph this. I'm going to be moving my whole graph down 1 unit, and so I'm going to get a bright color pen just so that I will no longer be looking at my x-axis as my oscillating line, but I'm going to look at -1. So I'm going to be looking down here. Okay, that's the line I'm going to oscillate around. What else? Let's see, our period is pi. So that means I have to do my crest and my trow within that movement. So right here, my sine curve, I'm going to begin at 0. I should have my ending though, because of my change in period, is here at pi, and halfway through is another intercept. Because my amplitude is 2, I'm going to go down 2 because my graph is flipping. I'm going to do trow first. So go down 2. All right, and then I'm going to go up 2 from there. I would be going down 2. And this would be another intercept, and then up 2 from there. So there's one wave and my second wave. And this will be reflected over here, so I would be having a crest and a trow, a crest and a trow, completing 2 cycles. All right, now I just did all the little X's there because I'm going to have to actually move pi over 2 units to the right. And I'm going to start on this side and then plot those points. So pi over 2 units, pi over 2 on this graph is going to be 2 of these tick marks. So I'm going to go over 2, so that's going to put me here. That point would put me here. Okay, so my intercepts are all going to really stay the same. Okay. But this point is now going to get moved over 2 units. This point gets moved over 2. This point gets moved over 2. This point gets moved over 2. Similarly up here, moved over 2, moved over 2, moved over 2. And over here, well, that's off the graph right about there. Okay, so now we begin with sketching. So what would we have? It would look something like this. When I do this, I feel like I'm sewing. I don't know if any of you have ever sewn anything, but that's kind of what it feels like. I know it would go to there and then back down. Whew, okay, that is wild. It is a lot going on. We're going to practice this a lot. You just have to be really patient. You have to go slow and carefully, making sure that every point you make is precise and then moved according to your phase shift. Number 3, a little different. We are looking at the graph. We know it is a sine curve, and we have a positive leading coefficient, and we want to find the closest phase shift possible, whether it be left or right. So let's begin here. First of all, I'm noticing that my oscillation is not like over my x-axis. It seems that it's actually oscillating right here. You see that? That is the line that's going to divide my graph with congruent going up 3 units and down 3 units. So that kind of starts to give me my equation, remembering that it's going to look something like this. Y equals A sine B x. I don't know if it's plus or minus. Well, I'll just put minus. Minus h, and then my plus. Okay, so I know right now a couple things. I know that it's a sine function, and I know that we are looking at moving up 1 unit. Up 1 unit, that's my new baseline. I'm also now able to figure out that my amplitude is 3, and it's a positive 3 because it said use a positive leading coefficient. Now I'm going to try and find my B value. Okay, so if this is a sine curve, okay, so my start of my cycle would be here, and it ends here. So that's, how far is that? Well, let's see. I'm starting at pi over 4 and ending at 5 pi over 4 because it's just one past. If I just moved this back, that kind of helps me to understand here. It is pi long, which means if my period, I'm going to do this in the little margin over here, if my period is pi, what's my B value? My B value must be 2 because that would cancel that out. So I'm looking at a B value of 2. And how much have I moved over? Well, it seems like right here that my sine curve, I would rather it start at 0, right? That's typically where it starts. But it's been moved over this much to the right. So that would mean for me that it has moved over. Oh, how much is that little bit amount? That's going to be to the right, pi over 4. And a right movement is positive, but we want opposite, so negative. Whew. Okay, so that was quite an analysis here. Now, just so you know, in typical response, you wouldn't leave it this way. You would go ahead and distribute that 2 out. So you're looking at y equals 3 sine 2x, and 2 times this is going to be 2 pi over 4, so that's minus pi over, that's going to reduce to 2 plus 1. All right. That is working with phase shifts. And So I'm going to pause the video here. This will be just part 1 of our chapter of our lesson here, phase shifts. And then next we're going to get started on graphing tangent functions. So stay tuned for more.